Welcome to your last circuit of Project 1, Circuit 1D, the RGB Night-Light. The only new component we'll be adding for this circuit is this long-legged clear LED with 4 legs, the RGB LED. An RGB LED is actually made up of 3 small LEDs, one red, one green, one blue, hence the name RGB. In a 4-legged RGB LED, all of the LEDs share a common ground, which is the longest leg of the LED. So there are 3 legs for setting the amount of red, amount of green, and amount of blue, and one for the ground. By changing the voltage we write to each of the RGB inputs of the LED, we can combine them to produce a wide variety of colors. But how do we write a variable voltage from our IoT breadboard? The analog pins we've previously discussed are analog inputs. They are good at reading a variable voltage, but we have no direct way to write one. However, we can use a fancy trick called pulse width modulation, or PWM, to make our digital pins act like analog outputs. If we quickly switch a digital pin on and off so that it is only on 50% of the time, to a connected device, it looks like the pin is outputting 50% of its maximum voltage. So, if we quickly switched one of our digital pins back and forth between its on state of 3.3 volts and its off state of 0 volts, both for equal amounts of time, it would output 1.65 volts. So we'll tie each of the 3 LED legs of the RGB LED to a different digital pin of our IoT breadboard, and then use PWM to change the voltage we are writing to each. Just like when we had a single LED, we will also need to add current limiting resistors for each of the LEDs in the RGB LED. That's about it for theory on Circuit 1D. Now let's build the thing. In this circuit, we'll replace our simple LED of our nightlight with the RGB LED. Pay careful attention to which leg of your RGB LED is the longest, and make sure that is going into hole A4, where we are connecting our ground wire. The other legs of the RGB will each have their current limiting resistor and then a wire tying them to one of the digital inputs. The photoresistor will be hooked up in the exact same way as last circuit. And finally, we'll add back in the potentiometer, hooking it up properly to power and ground and then tying its middle leg to A1. We'll be using the potentiometer value to decide what color to make our RGB LED. Now let's run some code on our circuit. As usual, the first few cells are to set up. Notice the 4th cell, where we set up a different PWM object for each LED. The next cell creates functions for setting the RGB to different colors by turning each of red, green, and blue to different values. Next, we'll try turning our LED red by calling the red function in the next cell. You can play around here by calling any of the other colored functions that we made above in this cell. For example, I'm going to run with blue, and then magenta. Ooh, pretty. Next, I'll check that my threshold is correct in this big old code box. We want it to be the same as the threshold we came up with for our nightlight in the last circuit, unless you've changed environments and your lighting has changed. Finally, I'll run this large code block, and we can see that both our photoresistor and potentiometer values are printed for our circuit. If we cover the photoresistor, the value goes down and our LED lights up. If we turn the potentiometer, the value changes and our LED changes colors. Congratulations, you've completed all of Project 1, Light. I hope you've learned a lot of cool stuff and that you're excited to check out Project 2, where we are going to be exploring sound. As always, stay safe, be kind, and happy inventing.